everyone. Welcome back to the AWS reInvent. We are here in the Launchpad. There's a lot going on today. We're going to talk about the launch announcements and bring you the service teams to discuss them. So make sure you're tuned in throughout the conference on your phone or at home. You can always see what's going on here on the Launchpad. And right now with me, I got the team from the storage and file systems. We're going to talk about new launches in the EFS, the Elastic File System, right?
Yeah.
And well, could you tell a bit about yourselves? I will let you introduce yourselves first. So I'm Julio, a technical evangelist, by the way. And here with me, I have...
Hey guys, I'm Drew Meyer. I take care of product marketing for the storage portfolio.
My name is Paul Reed. I'm one of the product managers on Storage Gateway and some of our EFS features.
And I'm Prashant Bangle. I'm a product manager for Amazon EFS.
Cool. And for people that's not very aware of EFS, could you give us a brief intro about the service and what it does?
Sure, I'd be happy to. So Amazon EFS is a fully managed file service. It's the latest addition to the overall AWS storage portfolio. So you have file, you have block, and you have object. So depending on what kind of interface and semantics and permissions model and things like that that your application requires, you can use one of the different services that we offer in the portfolio. So file in particular, you would use for applications that rely on a file system interface. For example, applications that rely on using the standard operating system API to read and write files, to create files, to lock files, and so on, that rely on file system semantics, things like strong consistency of updates, file locking, fine-grained permissions for individual files and directories, a hierarchical directory structure, things like that. And also having just in general applications that have been written over decades to rely on shared file systems and file interfaces in particular.
Yeah, so but the real magic here is the elastic part, right?
Yeah.
You don't have to buy a box anymore. You just get as much as you need.
Yeah, exactly. So if you want to do it yourself, that's a really important point. If you want to do it yourself, you would actually have to stand up a server, provision storage volumes and so on, and you have to worry about re-provisioning your storage volumes and reformatting your file systems and so on if and when you want to scale up, which you would want to do often. So with EFS, you only pay for what you use. Your storage grows elastically and shrinks elastically as your growth, your storage usage changes. And you only pay for exactly the amount of storage you use. And the good thing here is not only does storage elastically grow, but your performance that you can drive to your file system as well. Yeah, the throughput, the IOPS that you can drive against your file system also scales along with your file system size.
Cool. And just to make sure that you guys can take questions, ask on Twitch chat. We are here to help you guys understand and use this product, and the launch is better, so feel free to shoot your questions towards us. And the first one that I have as an application developer is, like, can this be done live with running apps and the volumes will just scale?
Yeah, absolutely. So we have a wide variety of applications, across the spectrum, everything from web serving, content management systems on the one end of the spectrum, all the way to really high scale out, big data analytics applications and HPC applications on the other end.
So anywhere that you would need a shared file system, right?
Exactly.
For sharing data between servers and keeping things warm. And
we're getting some questions though about when EFS or when DynamoDB versus sort of a traditional style file system. And I think that's an important distinction. Cloud native stuff typically tends to go towards API-oriented object storage. If something's already written to have an application that depends on a shared file server or file source, then EFS goes along with it.
Exactly, without any need to re-architect your applications.
Yeah, that's it. Like some apps you can use a plugin, for example, to write to S3, but some of them just write to a file system, and you need this data on many servers, and you need it to grow elastically, and this is what EFS is for, right?
Yep.
We have some great customers, like the guys at Spokeo down in Southern California. They used to run a Gluster self-managed file system in the cloud. They had downtime, they had a bunch of people running around taking care of this thing and babysitting it. really didn't want to be in that business, so they got out of that, they went to EFS, and now they can throw anything at it, it scales up, and it gives them the performance.
They've actually been able to achieve millions of page views a day.
Yeah.
If you're interested in reading the case study, it's up on our website.
I think this makes it perfectly clear what AWS EFS is and how is it important. But what's new about it?
Why are we here?
Why are we here?
Well, so this created a problem, right?
Right.
If you've got all your data on-prem, and yet you want to build a file system that sits in the cloud,
How do you do it?
what's in the middle?
Right. So just this last week, last Wednesday, just before Thanksgiving, we announced a new feature of EFS called DFS File Sync. The goal of EFS File Sync is to help customers that want to bring their applications into AWS and make use of EFS, make it easier for them to bring the data sets over from their existing storage on-prem.
So we have a lot of products for bringing data into AWS from the snowmobile
Yep.
to the storage gateway and several other options.
Yeah.
How does EFS Sync compare to the existing tools?
Yeah, so File Sync is, the tagline is faster and simpler. So File Sync provides a fully managed experience. Customers come to the AWS console, the EFS console, they select where they want to copy the data from, which EFS file system they want to put the data into, and they hit go. And we take care of moving that data. We've sort of speed tested it up to 5 times faster than standard Linux tools. We do a lot of parallelization, play a lot of tricks on the wide area network. We encrypt your data, so if you're moving your data over the internet rather than a secured connection, we take care of encrypting it.
I see.
And again, just providing a faster, fully managed experience from the AWS console. So faster
I
and
see.
simpler.
In fact, in
Yeah.
the old days, how did I do this before this?
Oh,
Yeah,
so when EFS first launched, until we launched File Sync, a lot of customers were scripting around this. So they'd take traditional
that's what I
command
thought.
line tools, they'd build scripts, the scripts would run. Sometimes if you're moving many terabytes or petabytes of data, they can run for days. And if that script fails, you've got to figure out how to restart, how far it got with the sync.
Yeah.
It's painful.
How to build it parallelism
How to do the
into
parallelism,
it,
yeah, all the rest of it. And
yeah.
and there's a number of frameworks that customers have deployed, but it's hard work. And we make customers do a lot of heavy lift. And we looked at that and we saw a lot of customers doing this who wanted to onboard to EFS and it was a problem for them. So we wanted to take that roadblock out of the way.
What do you see people building with it? What problems do you see people solving on existing
And
customers?
there's sort of 3 main problems that we see. So the first is migration, is this on-premises migration of file systems into EFS for customers that are on that migration path, moving their applications into AWS. The second, because we provide an AMI, an EC2 instance, so you can actually use this for taking existing shared file systems in AWS and move those into EFS. So if you've been running a file system yourself, a shared file system in AWS yourself, and the cost, as Prash mentioned, or just the overhead of managing it is too much, and you want a fully managed file system in AWS, first-class file system, we can help you move that data from where it is today into EFS.
Like, these guys at Spokeo had one guy's full-time job,
Right.
year-round,
To move
massaging
data.
this thing. Yeah,
Yeah.
this is like-
And the third use case, again, that we've heard from a lot of customers as customers start to use EFS across multiple AWS regions, is helping make the movement of data between EFS file systems in regions more efficient. So either doing a backup, potentially region to region, or data lake is a term. Customers want to consolidate multiple file systems into a single file system, perhaps in another AWS region. So on-prem to EFS, existing in-cloud file system to EFS, or even EFS to EFS.
Or even as part of their workflows, they might want to copy data from one file system to another
Yep.
frequently.
Yeah. So how does this work in typical architecture, if we can say, if customers have existing shared file systems on premises? For example, I see a lot of people asking about Pinox wants to replace his existing file system. It can just turn on his sync client and ship data over to AWS?
Yeah, so the way the service deploys right now is we, through the EFS console, you download a VM and you deploy that VM into your environment. And that acts as the mount point that mounts your local file system. And it takes care of doing efficient data transfer from your data center efficiently and securely into AWS.
Yeah.
So you deploy the VM, it pulls the data off your local file system and pushes it into EFS.
Yeah. I see some people asking about comparing this to sync clients. such as Dropbox or Google,
Sure.
Amazon Drive and similar technologies. Is there any comparison? How is this different?
There's a lot of similarities. Again, what we're doing is moving data, we're synchronizing data from one file system to another from that standpoint. Again, the biggest difference is this is a first-class AWS service integrated with all of the AWS management infrastructure from an IAM, KMS, CloudWatch, CloudTrail standpoint. And we're also really fast. We've worked really hard on doing super fast data transfer.
Yeah, and today it's to migrate data from on-premises to AWS, not the other way around,
Correct.
right?
Yeah, as it's mentioned, we launched it last Wednesday, just before Thanksgiving here in the United States. Yeah. And so we're actively looking for feedback from customers on other use cases that they'd like us to help solve for.
And guys,
Taco Dog, sorry.
Yeah, if there is anything that you guys have, any questions, any feedback for the EFS team, please just shoot on the Twitch chat. And well, I see someone talking about running EFS inside Lambda to run like tweaks in WordPress. Can Lambdas and containers mount EFS in some way? Is this something that you guys foresee?
Yeah, so containers mounting EFS is something that we see very commonly across our customers. That's a very popular use case for EFS. In terms of Lambda being able to mount EFS, that's not something that you can do today, but it is something that we are hearing a lot of feedback from customers about, and we are definitely actively considering it as part of our roadmap.
Cool. And anything else you'd like to highlight for people starting to use the service and people just getting started with this?
You know, I hear from customers in all different spaces. The trick here is understanding when should I use object storage and when should I use EFS, and then in the background, when do I use a block storage piece. The fundamental difference here is this is a shared file system. If you have multiple EC2 instances and you want shared data across those, like a classic NAS application for NetApp or EMC, EFS is the way to go if you don't want to refactor your application. And a couple of folks in here really got that.
Yeah, and I have some questions about how EFS scale. Like, is it based on CloudWatch? What are the metrics? When it scales? When it does it on your behalf?
Yeah, so as Drew mentioned, the number of clients you can access Amazon EFS file systems from can be tens, hundreds, or even thousands of instances. So in terms of multiple instances being able to access EFS, EFS already comes built in with a lot of scalability for your number of client connections. Okay. In terms of throughput and performance against your file system, the way EFS performance works is the throughput that your file system can drive scales along with the size of your file system. Specifically, we have a lot more details on the documentation, but specifically, you get 50 megabytes per second per terabyte of storage that you store on EFS.
Oh, so it's 50 megabytes per second per terabyte. So if you want to make storage, if you want to make it faster, you can just make it bigger.
Exactly, exactly.
We have a lot of zeros stored in EFS right now.
Oh, that's interesting.
I just wanted to clarify a point because the file systems are not pre-provisioned. You don't create a file system at size. You just create a file system, and then it elastically scales from there. So it's not that the file system has a size and has to be scaled. Create a file system and then start putting data in there.
And as you add data, your throughput scales.
Right. Don't think about it. Yeah.
Yeah. And well, what are the resources that people can use to get started? Like, what's the pricing looks and where to learn more?
aws.amazon.com/EFS.
Right.
Okay.
Or Google EFS.
I can. There's a lot of questions about Windows support and NFS. So just to make clear, this is NFS based, right?
Yes, so EFS supports NFS versions 4.0 and 4.1. We recommend the use of version 4.1 for optimized performance. And we also recommend that you use Linux kernel versions 4.0 or later to actually get the best performance. If you want to use this from Windows, today you cannot. It is something that we are hearing a lot from customers, and it is a very important thing that we are considering in our roadmap to actually add support for.
Yeah.
But let's just be really clear,
see
no
that
Windows support.
there is no Windows support, but because it can work for some cases it may not work. For example, you can. I know I'm not ashamed to say that I've shared a file system in NFS and SMB at the same time, and Dropbox and whatever. You know, we managed to find some ways to make the whole thing work, but it's not supported for Windows yet.
Yeah,
right?
that's a really important question because we hear from customers sometimes that they would like to use EFS maybe using some sort of an intermediate setup where they have their own Samba server that's mounting EFS and then re-exporting it as a Samba share or something like that. In general, that's not something we recommend to customers because Windows support is not just about supporting some sort of protocol access. For example, if you somehow get NFS to work or SMB to work or something like that, it's also about supporting the underlying file system semantics. For example, EFS supports full POSIX semantics, but Windows applications inherently rely on Windows NTFS file system semantics. So it's a combination of multiple things, not just the protocol access. So in general, if you want to benefit from the high availability and durability that EFS provides, if you want to benefit from the scalability that EFS provides and so on, it's best to use EFS as a first-class service directly rather than coming up with a sort of an intermediate layer in between and then that becoming a single point of failure and presenting scalability issues and things like that.
This is the whole point about DFS Sync, having the service manage security, parallelism, performance, and everything that's hard to make on these scripts and hacks, right? All right, that's I think that makes it clear how AWS DFS Sync can help customers. Thank you guys for joining us. And that's it. See you on the next launch.
Thanks so much.
Thank you.